This is a photo reactor long arc available, including the adapter, pump, and reactor, and the chiller. So when you start to run this experiment, set a suitable temperature with the chiller, flow the cooling water in from the side which has a longer tube. It lead the water to the most bottom, then flow out to the outside ports. Pay attention to the flow at the first time use. The chiller cooling water out connect to our in port, and our outlet port connect to the chiller flow inside. Pay attention to the direction. Must be flow in from here to the most bottom, then go out from this side to reach to the highly cooling efficient. The reactor, including trap here, is to cooling down the optical resource. So during running, this lamp should be located inside the trap and put until the most bottom. Then the lamp will be ready to use. The reactor is designed including 3 ports. One is for gas inlet. Gas inlet let the gas flow into your reaction. If you're doing saturation, you can use a flow control gas flow to saturate it until reach to your target. During the gas saturated stage, must keep any side open to forbid and overpressure. And this is a gas outlet that controlled by a three-way valve, can indicate by the T-junction to see the gas flow. Then this, if the T-junction was located like this, the gas can flow to both sides. And then if the T-junction located like this, then the gas will be blocking inside. Then the system will form as a closed system. And if the T-junction located at this, the gas will use at a single V to only go this side. If T-junction flow like this, the gas will flow like this to out from this side only. Then this side we are using to connect to your gas bag. If you would like to collect the gas to the gas bag during reaction, you can use this junction to lead the gas from here, then flow to your gas bag. If your gas bag is not enough gas to flow, then you can use a vacuum pump to pumping the gas sample to your gas bag. This is about gas collection. And for the liquid collection, we collect from here, and the tube insert in the most bottom, and collect here by a syringe. Then you can got the liquid sample. About the interaction of the system, the solubility balance and the liquid concentration, the catalyst loading, you need to be consider yourself based on the experimental design. Then when everything locate, you pay attention to your stereo bar and make sure the stereo bar was in the center, and you can start to use your magnetic stereo. This one you can set, follow your own menu. And the holder must hold properly, and make sure this top face to the top to forbid any dropping. Then to use this chain holder, you can refer to our old video about how to use the chain holder. You can release this one to the most bottom, but don't let it to be go out. Then this chain will be released. You can remove the reactor down from the holder. Then when the holding do the reverse operation to release here, hold the chain to the suitable position, then tight. This reactor will be hold properly. You can see I put a tissue here. This is during the loading, and the system will become very heavy when I have water flow in. So if after experiment you want to keep the reactor stay like this, you can put a piece of tissue here to forbid the gravity effect to make the trap stuck into the reaction. Use sink paper is better, and apply some vacuum grease in ordinary reaction, but don't too much to forbid contamination. If you afraid of the leakage, you can use perfume to sew in the connection every time when you apply it. To start the optical resource, you can put the adjuster to the 10 and keep this one on, then turn on the light. The light will be turned on, not immediately, but have a delay. You just wait the light to be on, then you will see what happened. Then to adjust, you can adjust it to lower and calibrate several different power intensity. Use your power meter to reach to your experimental requirements. That is about the experimental with photoreactor. Then there is a simple made sheet to cover for your optical resource to forbid to disturb other researchers in the same lab.